We are FTC Team 4327, Silver Titans, and this is our Control Award application.
We use this V-SLAM camera to navigate the robot around the field autonomously. It is constantly tracking the robot's position in both the X and Y direction as well as the bearing. It does not need a target because it takes its original position from autonomous initialization to determine where it is the whole time.
This is a demo of our V-SLAM robot positioning. On the right, you can see the V-SLAM camera tracking the robot's position as it moves in a square.
The front webcam is used to detect the number of rings in the starter stack. We use OpenCV to determine the amount of yellow, which is the color of the ring, that it sees. This allows us to deliver the wobble goal to the correct target zone in autonomous.
This is a demo of the OpenCV ring detection. On the left is how the webcam sees the ring stack. On the right is the driver station displaying the number of rings seen by the webcam. This is what happens at the beginning of our autonomous program to determine where the wobble goal should be delivered.
In our autonomous program, we use the V-SLAM camera to get to specific locations on the field. On the left, you can see our autonomous run, and on the right, you can see the V-SLAM camera tracking the position and trying to move it to specific locations. The green lines shown on the V-SLAM tracker represent the trajectory path the robot is trying to follow. The blue lines represent the actual path of the robot. In the high goal version of our autonomous program, we score both wobble goals, score 3 rings in the high goal, and navigate.
This is the power shot version of our autonomous. We score both wobble goals, knock down the 3 power shots, and navigate.
Moving on to driver-controlled enhancements, we have added automated features to be more efficient. One example is our high goal positioning. By simply pressing down on the right joystick of controller 1, the robot automatically travels to the launch line and faces the high goal. No matter where the robot is on the field, it will always get to the exact spot when this button is pressed on the controller. This makes it easy for the driver to shoot accurately and efficiently. Similarly, when the driver presses down on the left joystick, the robot travels to the position to shoot power shots. Once the robot is there, it automatically shoots the 3 power shots as well. This is really helpful because we can have more accuracy for shooting power shots even though we don't have much time in the endgame period.
Like we said before, there isn't much time in the endgame period. This automation moves the robot to the drop zone from anywhere on the field. As soon as we grab the wobble goal, the driver will press the button Y on the controller to move the robot near the drop zone.
We have the potential to do so much more. If you look at the driver station during this OpenCV demo, it actually tells you the distance between the ring and the robot. Using this, we have the ability to intake rings using a pre-programmed feature. For autonomous, this means we can intake and score more rings if there are any on the field. We have not implemented this yet because we don't have enough time left in our autonomous run. However, once we can speed up some processes, we can try adding this to the program. Another possibility is to completely automate the driver control period. Since we can detect rings, we could literally program the robot to intake and shoot rings without the drivers controlling anything. Then we could try and get the webcam to detect wobble goals so the wobble goal delivery process can be automated as well.